Hey everyone, my OBS stopped responding. I hope I'm still coming through. Hope we're all doing good. Uh, Drew, dude, yeah, Spectre, you need to up your game because Drew's just cleaning up on the first flames. Shit, there's a streamer that I like who has like an actual like channel point redemption just to say that you're first. Maybe I should actually do that too, just so I have something to do with my channel points. Actually, if think that like if I have that though, then I should make some kind of sound or something. And then that's a whole other can of worms. I don't know. I'll think of something. I still have to like figure out how to make the channel alerts actually like play stuff or the channel point stuff. I don't know. Let's look at what my DMs are. I have no idea what I'm saying. I stayed up way too late last night editing a video and I'm feeling it. They have. Oh yeah, this question. So this was the last time I streamed math. So friends use channel points sounds. Yeah, no, I've seen a bunch of streamers that have like channel points for sounds. I just need to figure out stream elements to do that, or if I need to get like another program to make it work, which I feel like there's a million programs you need to do everything you want. First, you should have opportunity to ask a question. I think every viewer should have opportunity to ask a question. Although, if you're just trying to like give a lot of fun to pull. Oh, I see where you're going with that. To me, the Paul question is the opposite of fun. That's my problem. Can't say expert protagonist. Oh, I'm those types of ones. Like I've seen the streamers have them. They seem really hard to track, and um, I don't know. It leads like mixed bliss with the streamer. The one Phasmophobia streamer. I'm thinking of it in particular who like will like wear a hat for 10 minutes. Like it seems to always just like get messed up. First viewer should have an order. I don't know. There's a bunch of things I still need to do for my stream that I just haven't gotten around to. Oh, okay. So yeah, there's a bit of ambiguity with how question or part C was asked. It's, the question was just find the number of children, like initially after 20 more joined and 20 more joined, but or the question was just find the number of children, but the nature, the setup of the problem was that you had an initial amount, 20 more joined, then 20 more joined, and so it's like which number of children? I should link my OnlyFans. Weren't you supposed to leak it? I don't. Maybe. I wonder if there's a market for um like nude tutoring or like sexy tutoring. Like I obviously have the body to pull that off. I just need to like find the market for it. Probability theory questions. I'm okay. You still have questions about like paint and drying? Actually, I mean paint drying is even the wrong comparison. Like paint drying is simple. Like you may as well ask me like a quantum physics question, I guess, is a better comparison. Um, Yeah. I if the person instantly saying to go with like the number of children partway through, then I'm just gonna let that be because I really don't know. So I'm just kind of saying to make it clear how they're interpreting it, so that way if they get dinged for not for like misinterpreting the question, they still got the right answer and hopefully can make an argument. Um, I guess it depends what you mean by probability theory. Like I've taken a calculus-based stats class where like you said like probability density functions and cumulative density functions. If that count, I don't know what I guess I don't think we ever called it probability theory though. If that is what that is though, then I guess I do a little bit. I have to like remember it, but okay. So this person had the limit of this function as x approaches 3, and I said they needed to factor the denominator as a difference of two squares, and they get a nice cancellation, and you get an actual value for the limit. Hard luck. It is indeed math time. Are we doing good? And the question was phrased very weird because first right, f is continuous everywhere except possibly at 3, but f isn't defined for 3. So, what the hell? A very simple probability problem? All right, sure. If you're saying very simple in caps, let's see. Oh, but wait. If this was the problem, they shouldn't end up with this. If this was the initial problem, I think it just is infinity. Or no, it's undefined. There is no limit. I would think. I don't know how the square root affects. Actually, no, it's probably infinity. Let's plug in the tool from alpha. Um, I almost want to reply back to this person. Oh, it won't be defined for x less than 3, but yeah, no, it's still infinity though. For the reason I thought it'd be like this curve, but then also mirrored onto this side. But of course it wouldn't because it's a square root. You can't have a negative in a square root. Um, Two friends want to meet between 10 and 11. Each of them comes at a random time in this interval and waits for 10 minutes and then goes away. Probability that they'll meet. It's very tempting to think of this like it's discrete and try and make something with like 10 out of 60. But I don't imagine that's actually valid because it's time and that's continuous. I guess. Oh, or maybe I'm thinking about it from the wrong angle. You could say like 1 over 6 squared for like 10 over 60 times 10 over 60. But I feel like that's too simple. Oh, you did say it was a very simple probability problem. So like some friends that they are just wait for 10 minutes and then leave. Um, This is like it's not quite, or it makes you think of Poisson distribution, but it's not. That's almost like the opposite situation. We have multiple things happening in one time period. Grissom was officially defined as being solvable by your brother, and he wouldn't solve that. Thank you, Spectre, for that definition. I really like that metric. If Spectre's we should like have that as a pin. Like if Spectre's brother can't solve it, I don't want to hear it. About geometric probability. Oh, we never did geometric probability. I've seen questions about it. There's also like hypergeometric, which I also never like studied. I don't think I did geometric. A pie diagram. Hmm. Maybe find another website. So, like, this part seems simple enough where like the probability that you're on this little line segment is the length of the small one divided by the length of the entire one. Wikipedia is too complicated. I could look at it, but they never provide like, or if you're completely I guess I'm not completely unfamiliar with the subject, but like it always explains things so the like you need a lot of background to understand Wikipedia's explanations a lot of the time. Okay, fine. We can look at it, but what? Oh, geometric distribution. Okay. How's this different from Bernoulli? Oh yeah, it's a special case of Bernoulli. But Bernoulli's for discrete. Can we think of it in a discrete way? That's not okay. Wait, I already looked at that one. No. Oh, Wolfram Alpha. Hey, here, Ben. How's it going? I feel like I've seen problems like that before, Drew. Honestly, I just like okay. If I find, thank you. Glad to hear it. How about this? We have 10, 11. We have a block of 10 minutes and a block of 10 minutes. That's way more than 10 minutes each, but you get it. You can find the probability that they overlap. So you can place one of these blocks anywhere you want inside the hour. In the other block has to start or end within the bounds of that block, which I guess the ends are kind of an issue. But if we just take it as a simple case, let's say let's just take like the middle part for when one person shows up. That means that we could have someone arrive potentially 9 minutes before that, all the way up to the same time as they leave. So 19 out of 60 possible minutes. And maybe the ends aren't an issue because you can always just flip who you're thinking about first. But you basically, I think you just take one, you put it wherever you want, and then you look at the other one. So is it 19 out of 60? I don't know. Arrive close to 10, and the other person can't arrive earlier. Okay, so that it is an issue, I guess. So then if we look at the other, this is the simple case, I guess. Wow, that's not the same size at all. So if we do have someone who arrives at the very start of the time, the other person also has to arrive. Well, they can arrive between like basically 0 and plus 959 or plus 10, depending on how you want to like do things. So, well, you kind of get a sliding scale because then if the first person arrives 1 minute after 10, then there is a wiggle room of 11 minutes. So, do you actually need to set up a function, or you at least could? Would you go for 2D? Okay. No pun intended. So yeah, so maybe you do need the area under the curve here because it like first arrival time. Um, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So if the person shows up right at the start, the other person needs to show up within the first 10 minutes. Hey, fun buddy. Well, if it makes you feel any better, I also don't understand how it works. Oh, and here, Ben, thanks for the follow. And as we go out to the 10-minute mark, the other person can arrive within 20, or I guess 19 minutes, or I guess 10, or within like 20. I guess it depends on, we can let minutes be continuous, especially because if we're graphing it like this. And then we just have like, I mean, I think my axis labels are a little bit like weird, but I'm thinking like the y-axis is basically the amount of wiggle room that you have to arrive by. And this line, and the answer we want is the area underneath this function. I guess it would need to be scaled so it all adds up to 1. But I feel like you account for basically the straight, or like the that diagonal line there plus the straight line. And you get your answer from that. Which I don't know how you scale this actually. Because I mean, I like this part, you would make it if it was all the same continuous, or if it was all the same like function, if it wasn't piecewise, you could just make it like 1/60 times that or something. Make it add up to 1. Or is it not important if it adds up to 1? Can we just find the area under the curve and then scale it after? Well, if we do want to find the area of the curve, just geometrically, because it's all straight lines. The area of that square is 10. The area of this right triangle is, I guess 1/2 10 times 10, which is 10. The area of this part is 50 times 20 is 100. So in total we have 120. X amount of times at which the friends come. That is how I labeled them too, actually, but I graphed it in a different way, which maybe isn't a good idea. But I mean, for the second friend, it depends on the first friend. If we're looking at the parts where they overlap, right? So how do you like graph that? Because, well, I guess if they wait for 10 minutes, they can't arrive at the 60-minute mark. So I guess the latest we need to worry about is 50 for the actual arrival time. You find the area where they even meet. Well, if the first friend gets there, I mean, if we take the middle point, if the first friend gets there at 30 minutes, we have multiple possible values on y. Because it could be from 20 up to 30. So you get like you could put 30, 30, but I feel like it's not a function. You just have like 30, 20 and everything in between. That's where I get confused on trying to graph it like this. A intersect B equals P of A times P of B. I think it wouldn't be here, Ben, because we're talking about like a continuous variable, so I don't think that formula applies. Or at least not exactly the same. Maybe 0.613. Do we have two functions? And we find the area between them? One for the latest the second person can arrive, one for the earliest the second person can arrive? I guess, yeah. Need to draw the area where they meet. Okay. Well, at least for 10 minutes and after. I'm not worrying about the before 10 minutes part yet. Do we just give like two, at least for the part on the right, wouldn't we have like basically two lines that have a constant slope and we have to find the area between those? Up to the 50-minute mark. Almost got it? Okay. And then, I mean, I guess we can allow them to come after the 50-minute mark. Uh, Although that might be a little bit like ambiguous what that actually means. Or like, you know, how they still wait for 10 minutes. But if the first person arrives at 60 minutes, the other person also have to arrive right at 60 minutes. Well, actually, no, they could also arrive. No, they could also arrive 10 minutes before. Okay. So maybe it is just the same thing all the way through for this first part, or the last part. Got it a little more precisely. All right. Let me get the tick marks in order then too. One, two, three, 4, 5, 6. 1, 2, 3, 4, 5. I have to redo that 5. 5, 6. Let me erase this case up here. Okay, so the first one, or redoing this, first person arrives at the 10-minute mark, not worrying about the before 10 minutes. The other person could arrive for lines at a 45-degree angle. Okay, yeah. Second person could arrive at the 20-minute mark or later. And I think I just come to the conclusion that can be true all the way up until the end. We'd have 60-50 and 60-60. Okay. And then before, if the other person arrives at 5 minutes, the second person would have to arrive between 0 minutes and 15 minutes. It's not 45 degrees. I mean, it's close enough. Like, I'm not gonna break a ruler out. I just know like it's basically a line with slope 1, and they just both have different y-intercepts. Unless you meant I actually. Oh wait, I guess you're right. Never mind. No, I'm sorry. I thought you were criticizing my drawing, but these aren't 45 degrees. But we do have the point. Wait, we start at 10:10. For it to be 45 degrees, we have to end. This would have to end at 60-60. But that's not true, though, is it? Because if the person gets there at times 60 minutes, the second person could get there at 50 minutes or at 60. So wouldn't it be the time between 50 and 60? Unless I'm double counting cases. If we are saying first and second arrival, I guess. Start at 10:0. This one should be shifted down by 1? Oh, I guess so, because if the first person arrives, or if we're saying, one person arrives at 10 minutes. The other person could show up at the 0-minute mark. And similarly for this one, I have to get shifted down. I think I'm confusing myself a bit with the whole first and second terminology. So those will be 45-degree angles. The other one starts at 0:10 and ends at 50:60. At 50:60, really? I guess this makes sense now that I look at it. It's really hard to think about, or I was finding it hard to think about though. Okay, I mean, I guess we could integrate for this. You could do it geometrically too, but you'd have to do a bunch of Pythagorean theorem stuff that I'm not that interested in doing. Not really that much, but I mean, I guess it makes sense because if the first person shows up at 0 minutes, the second person would have to show up by 10 minutes, and there is no minimum. And then the same is true, but reversed with this starting point here. Oh, and so the answer would be basically, what area does this rectangle plus triangle reside in compared to the entire square? And that's your probability? It's easier to do geometrically. It is good. It can be symmetric, but makes it a lot easier, I guess. I thought that I guess if we're keeping that part, yeah, that's a good point. Because oh yeah, because for the same reason, if one person shows up at 60 minutes, the other person could show up anywhere between 50 and 60. Okay, good. Yeah, good point. 2/6 to the 5th equals 1/3 to the 5th. I think it's still thinking in discrete terms here, band. So I guess this actually isn't that bad to do geometrically because you have a right triangle on the lower right here, an equal, or I guess congruent one in the upper left. It's a right triangle, they even have equal legs, 50 and 50. So the entire area of the square is 60 squared. Probability, ugh, my marker's dying on me. Let me switch to red. Probability that they meet is the area of the strip, which is 360, which is 60 times 60, the entire length of the square, or the entire area of the square, minus 2 times the area of, let's just take this right triangle, because it's congruent to that one. 50 times 50 is 250, so that's base times height, times a half is 125. And actually we multiply it by 2, so that's pointless. Divided by 360. 360 minus 250 is 110. That simplifies to 11 over 36. Is that right? Eleven over 36 is 0.30555. Okay. That's actually pretty close to a third, which is funny that that's kind of where I was going with it initially. 1136 as a date? What date would that be? Unless 36 is the year. I just want to see how Wolfram Alpha is going to interpret this. Oh, okay, it is using 36 as the year. Okay. All right. Well, thanks for the problem, Jura. I usually prefer doing the ones that people actually like need help with, but sometimes also in the mood just to do problems like that. So thank you. All right, so for this person, they were doing this limit with root x minus root 3 over x minus 3. I gave them the simplification they do with the denominator. Problem for basic knowledge. Yeah, it's a good, I guess, like technique to know. Just the same with the graph is super weird. But thanks for helping me through it. I do want to be clear to this person that they said that they misread the problem and it's supposed to be this, but this, like, that does not simplify to this. So I almost want to write down both of these problems and kind of show the difference between them and take a screenshot of it and post it for this person. Because they mentioned that they're really bad at math, so I want to make sure they get this straight. So I'm going to write this down with the intention of taking a screenshot of it for this person and posting it. Actually, how's the black marker doing? I haven't used it in a while. Maybe it's feeling happier. Limit as x approaches 3 of root x minus 3 over x minus 3. I mean, I'm going to like show a quick graph of it. is equal to infinity. So I want to be clear that like this problem is infinity because the graph looks like that. I think it's the simplest way for me to convey it to this person. But if you have limit as x approaches 3 of root x minus root 3 over x minus 3, this you can do something with. Which is factoring the denominator as the difference of two squares. So limit as x approaches 3. The numerator stays the same. The denominator becomes root x minus root 3 times root x plus root 3. And if you want, you can multiply these back out. You'll get that same denominator back. And now we get a convenient cancellation with that and that. So limit as x approaches 3. Now we just left over with that in the denominator. So 1 over, which equals 1 over 2 root 3, which equals root 3 over 6. So I want to take a picture of this and post it for that person. I'm to show whether the infinite sum converges or not, but it's complicated for you. Ooh. I mean, I could take a look at it. If it's complicated for you, I don't know if I'll be able to do it, but maybe I can come up with an idea. I'm gonna open up my own stream quickly here and take a screenshot of my monitor or of my stream. Give me 1 minute. My stream might freeze for a second. I don't know how this is gonna show up for you. Okay. Took a screenshot. Let me save it, and I'm gonna need to upload it. Pictures. Okay. Open up Imager. You guys can see what I'm doing now. There. Okay, so let's glad to help. But to be clear, does not simplify to it's a bit easier to show actually in this image. Oops, that's not right. Does infinite sum of a sub n converge with you take the sine of the previous value recursively? That's going to be a hard one. Actually, I guarantee you Imager is marking this as 18 plus, right? That's just a thing now. Oh, no, it's not. Okay. For some reason, this image isn't sexual to Imager. All my other ones are. It is some pretty sexy math that I do usually, so I guess I get it. Okay. since it's a bit simpler to see drawn out than typed on it. You had an accident today? What was that? Occurred, status 500. Or an error occurred, status 500. Okay, well, that's great. Let me try refreshing. I was trying to find out how to pronounce the word Linux. It's like Linux, as far as I know. Oh, is the browser not even working right now? Ugh. Or is Reddit broken? No? I still don't find it in Firefox. This frickin' thing. Linux prawn. I'm sure that exists. I don't know what it would be about. Some Linux porn links. The hell? Why can't I post? Okay, let's go to Firefox. I don't know why Opera doesn't want to work. Um, yeah, I mean, I'm sure you learned your lesson. Okay, I don't know what Opera's problem is. Okay. Okay, but this hypothesis test question. Really? This is a weird setup. An approximate hypothesis test. Dude, I've been able to feel a sneeze coming on for the last like a minute, and I just won't sneeze, and it's really annoying. So I have a little like tickle in my nose. Oh yeah, that's definitely a stereotype that we have here too. Just like an emphasis on like academics in general. Conduct an approximate hypothesis test to determine if this sample provides evidence the majority of the Victorian population supports the voice. Japanese and Indians, you think true? Oh, I mean, it's always like a generalization, I guess. Like, I haven't like looked at anyone's like test scores, but I'm sure you could find like, one or a few countries that test way better than the rest of the countries. Yeah, I have heard that, but like In some countries, they like learn calculus way earlier than they do in America. I have no idea if it's true, or maybe it's just like the only most advanced students. But I think everywhere, it's never like everyone there who's good at math. What's up, Jeb? Okay, so I think, oh, I mean, I guess I'll wait to hear Jed's question, but I think for this one, if you were doing like an actual study, you would throw out the undecided people, or, just for the sake of doing a hypothesis test for supporting the voice, you would only worry about the 59 who were decided. You want to phrase it properly? Okay. Uh, yeah, you're right here, Ben. There's definitely a difference between memorization and understanding. But I think a lot of times it does come along with that. Like the students who, or the students who are testing really well do have that understanding. Or at least, I don't know. I guess it depends. I'm not that like worldly. I don't know how other countries work. Start typing a response. People who would only be concerned. Well, because you could take the undecided people as not, you could assume the worst and that they don't support it. Or, the worst, I guess, depending on how you define the worst. Never mind. Okay. This seems like more like a best practice thing or a context dependent thing. I wonder if this is gonna show anything helpful. Meh. Oh, hit a chi-square. You don't like this question? You could do a chi-square and like set up like a table and assume that you would, because this is weird bringing things up, but you could do a table with like 3 rows. First row is for in favor, second row opposed, third row undecided. And you would expect them to be equally split, 33, 33, 33. But you can use a chi-square test to see if there actually is a statistical difference from that expected equal distribution. Right, Jed. That I would think. And these people are Victoria. I assume enough that 100 isn't too big of a sample. At first I read it as like there's 100 total non-Indigenous people in Victoria. And that, sample 59 out of 100 is way too big. I feel like I've heard that actually a bad thing to have too big of a sample. Or like that's what some of my stats teacher said, but I'm assuming it's a very big population to the point where we don't have to be concerned about that part. Actually, this is weird. A sample of 100 non-Indigenous voters provides evidence of a majority of the Victorian population. This feels like a bad experiment design, experimental design. I see. Okay, yeah. You, I would think this is context dependent because the question as phrased as non specifically or samples specifically, actually not as phrased, as asked, non-indigenous voters and asks to generalize all Victorian voters, which seems improper, I guess I'll say. The sake of just trying to get an answer, what you've been, stats class, I think it might make sense to throw out the undecided part of the sample and take n equals 59. But again, there's many ways to go about this. Is our Amish, they don't believe in centralized governments, they vote against this issue. That's do Amish people actually believe that? I've never I live very far away from the Amish people, so I never actually like met them. No, just an example. Yeah. Yeah, no, this feels like improper stats. Like it's bad to teach students that this is like proper. I assume it's just like in a homework question on their like Pearson online site. They just have to get an answer. But like this feels like horribly constructed. Any ways to go about this? We needed, or if we needed to include, well, 3 of support, against, and undecided, I think the only option is a chi-square test. I'm just gonna leave it at that. Because they might not everyone learns chi-square, I don't think, or at least they don't necessarily learn it for this particular type of situation. I feel like chi-square gets taught differently in every stats class. The way that I learned it is different from how I see people using it. Let's just post this and hope that helps them a bit. It's just a weird question that I don't really like. Helping so confused and crying? Aw. Let's see. Oh, this looks like a Jed problem. I see weird shapes. This diagram shows a hexagon, A, B, C, D, E, F. Does that count as a hexagon? I guess a hexagon is any 6-sided shape, right? Or, I guess specifically this is a chevron, right? A, B, E, F, and C, B, E, D. Basically, if you slice it along that like dotted line, each of the things are congruent parallelograms where AB equals BC equals X. P is the point on AF. Link, please. Yeah, sure. and Q is the point on CD such that BP equals BQ equals 10. Given angle ABC is 30, prove that cosine of PBQ oh my god, okay. I need to draw this out because they only label half this problem. Okay. Okay, that vertical lines, that's, oh my god, I'm already, this black marker is way too faint, dude. Just stick to red. Actually, I don't like drawing primarily in red. The green, sit down. Just try blue, see how it works out. All right, that's looking decent. A, B, C, D. Okay. Going around clockwise. P and Q. Okay. And then ABC is 30. And what we want to find is PBQ. You're up to watch topology lectures? All right, Drew, have fun. I know I wouldn't. Prove cosine PBQ. It's 1 minus 2 root 3. Wait. 1 minus in the fraction 2 minus root 3 over 200. That x squared? Oh god, not like that. Ugh. X squared, okay. And we threw out some more information I didn't write down. AB equals BC equals X. BP equals BQ equals 10. Let me do that in red. So why can't we just make this right triangle? Because we only have the hypotenuse and no other information about it. What? Oh, Donkey, thank you so much. How's your stream, man? Mom, thank you for the follow. We've come to learn. Well, I hope you also enjoy watching me fail, because that's usually what I'm doing half the time. It was chaos as always. Oh, good. Yeah, thank you so much. I appreciate you. Welcome in, everyone. You don't know P, E, Q are linear. That's true. We don't know that. Or that PEB is right angle. Oh, okay. Yeah, you got me there. Oh. Yeah, we got to use that. They're parallelograms. It's kind of weird that it's like we just boil this down to one. Like, surely we have to use the entire hexagon in some way, but couldn't we solve the problem just by looking at one of the parallelograms? Let's just take ABEF. And we have point P goes there. X 10. The entire angle is 15. You ever smell this giving you PTSD of high school? I don't know why I always try these geometry problems because they're always so confusing. Normally I like doing like calculus or something like that, but sometimes they just look tempting and this will look tempting. It's all good. Um, ABC is bisected by BE. Triangle ABC is bisected by BE, right? AB is 15. Okay, yeah. FAB is 165. Yeah, because they have to add up to 360. So it was 265? 165. A parallelogram, it means all sides are parallel, but not necessarily the same length. So you can have a very like long parallelogram or a very like short one, I guess, right? It's not necessarily just a square. Same length would be rhombus? No, not a rhombus. I don't think so, at least. Oh God, Wikipedia, please stop. I get it. Uh, oh, sorry. I should probably actually pay attention to what my browser is showing. Yeah, so you're right. It's not necessarily. Say my. All right, rhombus. Oh, I was thinking of a trapezoid, or oh yeah, I was actually thinking of a trapezoid. All right, my favorite phrase, Jed. You're right. Like always, your geometry is just on another level. All right. Maybe that thing about the diagonals is going to be handy. I don't actually know. But yeah, all we know with the parallelogram is that all the sides are parallel. And the opposite sides are congruent, but not all four of the sides necessarily. I bet you we have to draw an isosceles triangles somewhere. The we're gonna need to name another point somewhere else to figure this problem out. I don't know what that is though. Also, I saw like maybe we need an equilateral triangle or something too. Triangle ABC has angles 75, 75, 30. ABC. 75, 75, 30, right? Maybe we need to. Would it be helpful if we named a point down here that such that like this point R or whatever also has length 10 and 10? Does that get us anywhere? That would be a rhombus. I don't. That just seems. I don't think it's going to do anything that helpful though. It's only the. This is also X. That's also X. That's also X by it being parallelogram. I really want to do something like that and call that length 10 to make an isosceles triangle. I just don't know what you do after that. You could maybe try to figure out some angles. Because you still, if you look at the entire quadrilateral that creates, you still have to add to 360. Hmm. Your brain boiling trying to understand you almost failed math and you were in the easiest class. um My brain is kind of melting too. I'm about to just like move on, try and find another problem, but this feels like one of those ones that you need to find the right thing to draw on this, and that's always really hard. So what's here, Ben? You're saying Al-Kashi. I never heard of that. Oh, law of cosines? I was thinking about law of cosines, but isn't that... Woohoo! How have you been? How's art school? It's great to have you. Okay, you feel the same. You want to be good because you loved engineering physics in school. You just sucked at the math bit. um, Honestly, like I'm almost like the opposite. Like I never really liked math, and then when I started taking some more advanced classes, I started to really like it. But there's some stuff that I still hate. Like, well, I don't hate geometry, just some problems get a little too out there for me. Um, Sorry, I keep forgetting about my browser not being expanded. But the law of cosines, what Hirban is saying. I'm good too, hoo hoo. Thanks for asking. Why is this expanded? Wait, why is this so huge? Oh, because shoot, I made it bigger and I shouldn't have done that. It's pretty boring? Oh, well, I hope it gets more exciting. I guess you're only just starting. Um, I've been helping you in 10 years. You worked in a garage either, which was lucky. Yeah, I mean, I'm not those people who tries to say that you use math, or you're going to use math every day of your life. Like, it's fun and it is in everything, but you can live your life without knowing it. But on BBQ become easier. Oh yeah, so all we would need is the length between P and Q. Okay. That actually, yeah, that's a good point. Just let it with power 2 without square root until you find cosine gamma equals cosine BPQ. I wonder if we somehow relate it to the other isosceles triangle with ABC. I don't I don't know exactly how we'll do that, but um, yeah, I hope it gets exciting for you. Do you have to like move out, hoo hoo, or are you still like able to live at home? P and Q both way. Oh God, we're getting to the Jed's doing his like Euclidean tactics. P and Q both way on a circle centered at B with radius 10. Wait, P and Q both lie in a circle centered at B with radius 10. Or a comment and a question. Okay, yeah. Maybe that'll help. I don't see how right now though. Let's just I guess write out the law of cosines here and do that much, I guess. Oh, can we say that AC is equal to PQ? And we're going to do the law of cosines on ABC. It must be something like that. A and C both lie in a similar circle radius X with the same center. Yeah. So, okay. So yeah, PQ would be C with the law of cosines. So I'll say PQ squared equals PB squared plus BQ squared. I'm being sloppy with the alphabetical, but who cares? Plus 2 PB. Dude, that makes me want some PB and J. Cosine PBQ. Okay, so we still don't know PQ. We do know PB is 10. BQ is 10. 100 plus 100 is 200. Plus 2 times 100 times 100 is 200 again. Okay. Hey, Superbase. If you want to put your question right there in chat, or if you'd rather take a screenshot, you can feel free to put it in my Discord. I have a math questions like channel. Oh, minus, thank you. And Jed spotted it too, yeah. Thank you. So now if we apply the law of cosines to ABC instead of PBQ, we know, actually, I'll even say PQ squared equals AC squared equals, I feel like it's not too much of a leap to just say PQ equals AC. 2x squared minus 2x squared cosine 30 degrees. Cosine of 30, why can't I do math? Root 3 over 2. Two x squared minus root 3x squared. Okay, so there's our 2 minus root 3x squared over there. Oh wait, this actually is really, we just plug this in over here, and then we have our cosine PBQ. I was going way off the deep end with this. Oh my god, okay. This is just like the answer right here. Okay, really good call on that here, man. Thank you for saying that. So I already said PQ squared equals AC squared equals this. So PQ squared equals this. Plug 2x squared minus, I mean, I'll even factor out the x squared. So make it even more clear what's happening. Plug this in over here for PQ squared, and then we just solve for cosine PBQ. 2 minus root 3x squared is equal to 200 minus 200 cosine PBQ. Now I just solve this algebraically. So subtract 200 from each side, then divide by negative 200. So we'll get a positive 1 minus 2 minus root 3 over 200x squared equals cosine PBQ. Okay, that could have been, I thought this was going to be a way harder problem. I was in the mode of like trying to like draw fancy stuff. Back to the 200 first. Oh, yeah, you're right, Jed. Or just all do it as mental math. Yeah, super based. Yeah, just feel free to type the question right there in Twitch chat, and I'll let you know if I can answer it or, yeah, whatever you're most comfortable with. Let's see if anyone else has responded to this. Okay. Um, feel bad about not being about not getting it, I guess. I want the person to feel a bit better about not understanding this problem, because I only solved it because Kirban put that. Or, you know, said like law of cosines. Um, Math is Fun is a good website to link. Okay. First, connect P and Q. So that PBQ makes an isosceles triangle with BP and BQ. This makes you want barbecue equal 10 cm. And P, and we don't know PQ. Cosines on this triangle to get PQ squared equals 10 squared plus 10 squared minus 2 times 10 times 10 times cosine angle PBQ. Am I solving it or helping? I feel bad when they say, help, I'm so confused, I'm crying. I just want to give them the answer. Like, you're right. I technically should just give a hint. But I also just want to kind of help them out. Let's take a look at that. Super based. Oh, okay, so we need to get the equation of this circle. Um, yeah, let me, since this person on Reddit can wait, since it's like, and well, uh, actually, it shouldn't take me that much longer to type out this answer. Let me just do this quick so I can erase the board and draw your problem out for you. I can definitely help with it though. Okay, how about this? I'll go up to like the last few steps, and then I'll stop. We can connect A and C to form another isosceles. 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 AB will BC equals X CM, and AC is still unknown. So AC squared equals x squared plus x squared minus 2 times x, oops, times cosine 30 degrees. I'll leave the last few steps to you unless you ask, but now we need to notice that AC equals PQ, and we can substitute the equation for AC into the first equation for PQ. Okay, that's a happy medium between not giving away the answer and trying to help out a person in distress, I think. Okay, so let's post this and get to super base question. Thanks for hanging on. I just wanted to finish my train of thought there. So you say that you know the equation, just not sure how to plug in the numbers, which I can definitely show how. This red marker will ever erase. Geez. Okay. Okay, I'm having the black like sitting like that, so hopefully the ink is you know what the general form of a circle looks like? Okay. So let me first I'll redraw the picture and then I'll show the general form for a circle. I'll draw just the positive. Oh man, it's still dying on me. Okay, fine. So use red. Actually put this black marker over here so it's standing up and dang it. You'll take notes? Sounds good. There's also always the VOD as well if you want to like if I erase something too soon or something like that. Yeah, for this first part, I'm just gonna redraw what you sent. So we need to go 5 over 1, 2, 3, 4, 5. We need to go 4 up 1, 2, 3, 4. And I guess we can do x and y for our axes. We have a point at 3, 0, 5, 2, 3, 4, and 1, 2. Okay, this doesn't look very much like a circle, but let's just pretend like it is. Your teacher's kind of going through things very quickly and not really getting it. We did linear equations make sense to you, but circle stuff is confusing. Oh, okay, yeah, if your teacher is going quick, it's easy to get lost in what all the different formulas mean. So what Jed was asking about is the general form for a circle. And so we definitely want that. It might be shown in slightly different ways. So if you're taught it with different letters in class, it's fine. Where it's still the same thing, just it'll look slightly different. But the general form for a circle is x minus a in parentheses squared plus y minus b squared equals r squared. And a and b are the coordinates of the center. And r is the radius. Oh, h. Yeah, H and K are much more common. I actually forgot that those are the more common ones, but H, K, A, B, it's all kind of the same like end result. So yeah, Jed is right. So we have the kind of outside points of the circle here, but that's not helpful to the formula because we need the center and the radius, but we can use those points to find it. So the center is, you know, we can just kind of, well, it's a circle and finding the center is just kind of by looking at it. Hey, Alti, you always use x sub c and y sub c? Oh, I mean, actually, yeah, that's honestly a better thing than h and k, I think. Oh, you do know this? Okay. Do you want me to still show it like all the way through, or are you actually good now? You're from as h and k? Oh, okay. That's a good call then, Jed. Let me actually change it. Honestly, I think Alti's thing like makes more sense, but since it's taught h and k to most people, I should use h and k. Um, yeah, I'll keep on going through unless you say that you're good with the problem. So the center of the circle, I just kind of like, I hope this isn't too hand wavy, but it's a circle, so we can just look at it and see that the middle of it is going to be right there. And when we look at the coordinates, x is 3 and y is 2. And so yeah, Jed, that's a good question. That's the confusing part. Okay, so I mean, focusing on the center first, then if you're not comfortable just like looking at it like I did and then looking at, where it meets the x and y, you could say that on this, you could look at, let me erase the center. We are given these 4 points, and we can connect the top and the bottom and connect the sides, and where they intersect is going to be in the center. And we can figure that out numerically without even needing the graph, because we know this goes from 1, 2 to 5, 2. I have the form of like -3, 3, r equals 3, and then how do you graph it? Okay, so this is like going backwards. What we're trying to do with this question. Three zero three four. So we're trying to find the center like a bit more numerically than just looking at it, like I did. Let's look. We can basically find the halfway point between these two lines, and that's their intersection point. So this horizontal line goes from 1, 2 to 5, 2. The y values are the same. It's just the x values that are different. So if we can subtract one x value from the other. 5 minus 1 is 4. So the entire thing is length 4. That means halfway through 4 is 2. Or halfway between 1 and 5 is going to be basically 2 away. So it'll actually be at x equals 3. So I'll put like 3 comma and then a blank. So we just know that, if we're going halfway between 1 and 5, that has to be 3, because there's 2 on either side. I hope I'm not explaining this overly complicated. And we can do the same thing to get the y coordinate, because we go between 0 and 4. And that's again, or not again, but it will be 2, because 2 is halfway between 0 and 4. So you go, basically there's 1 between 0 and 2, and there's 3 between 2 and 4. So here we can get the center is 3, 2. I don't know, there's an even more complicated way I could show how to get like the center just doing purely math and not having to look at the graph at all, but I feel like I'm making it really complicated already. So there's different ways that you could find the center of this. Jed is right. I was thinking of the midpoint formula. So, I mean, I'll just show that. How about this? I'll show a few ways to get the center, or I'll show the midpoint formula too, and you can do whatever makes sense to you. How about that? So I feel like I'm explaining it in 5 different ways right now, so I'm sorry if I'm hurting more than helping. But another way is that since we're given 2 points across from each other, we can just take the midpoint of those 2 points and know that that'll be the center. So the midpoint formula is for any 2 points you want, it'll be x1 plus x2 over 2, comma, y1 plus y2 over 2. So if we take the two, like 1, 2 and 5, 2 points, as long as they're across from each other, our first x is 1, our second x is 5, divided by 2. Our first y is 2. Our second y is 2. And divided by 2. 1 plus 5 is 6. Divided by 2 is 3. 2 plus 2 is 4. Divided by 2 is 2. So we get 3 comma 2 again. Yeah, what Jed said is the way that I would prefer to do this problem personally. Of course, you can do it however you want, but to me, just counting is like the quickest and easiest way. But there are many different ways to find the circle, which is why I was like running over myself to do it in many different ways. But since it is drawn to scale and you have the coordinates right there, I would just count as the easiest way. So I hope I haven't lost you yet, Superbase. Please say something if if I'm going too quick or saying things that you already know. But the counting method is the way. Okay, good. As long as you're comfortable with any way of finding the center, just go with that. Whatever you like the most. But if we're okay with the center being 3, 2, however you happen to find it, that's going to be our h and k. So let's plug h and k in, 3, 2. So x minus 3 squared plus y minus 2 squared. And it is a little bit weird, but it is minus 3, even though it's plus. Even though we had positive 3, but we end up with minus 3 because the formula has a minus, and that's okay. If it was x plus 3, that'd actually go with a center for negative 3 for x. So just remember the sign is flipped in the formula. It throws a lot of students off. But x minus 3 squared plus y minus 2 squared goes for the center of positive 3 and positive 2. The only thing left now is to find the radius. And since you're comfortable with doing the center the counting way, let's also find the radius in the counting way. So remember, the radius is from the circle out to the edge, or from the center out to the edge in any direction we want. So, I mean, I'll just count from 3 out to 5. Like, basically from the center out to this point on the right. Start at 0. You go 1 over, you go 2 over. Your radius is 2. Because we just hit our 0.52 on the edge of the circle. So 2 squared is 4. Well, let me write it on a different line. The equation of the circle is x minus 3 squared plus y minus 2 squared equals 4, and I would call that the final answer. Yeah, if you're given like the coordinate axes and stuff like that, and it makes it easy to count, I would just count. Oh, and yeah, if you're really unsure, I think where Jed is going with this is you could check it by taking any of the other 3 points on the edge of the circle and plugging them in for x and y, and you should get a true statement. So if we want to verify our final answer, let's take 3, 4 and plug it in for x and y. So x is 3. 3 minus 3 squared plus 4 is y minus 2 squared equals 4. 3 minus 3 is 0. 0 squared is still 0. So I'm going to leave that out. 4 minus 2 squared is 2. I'm sorry, 4 minus 2 is 2. 2 squared is 4. So we get 4 equals 4. That's a true statement, so our answer is probably right. This is the general form, yes. Superbase. That line is your general form. Or center radius form. I feel like I normally hear it referred to as the general form. But I think Superbase said center radius, you're right. Okay. So I hope that makes sense. I'm sorry that I explained it so many different ways because I am scatterbrained. Let me know if you have any questions, or if you have any question on that, or if you have a completely like separate question you want to see too. In the meantime, I'm going to start looking for other questions on the internet. And thank you for that question, by the way. It's always nice to have people who are actually like coming into chat with questions rather than trying to scavenge for them online. Really? There shouldn't be different ways to represent it. You could multiply out the x squared and the y squared, but that doesn't, I don't think it's a form. This is the general form? I hate that. Wait, so do you need it in general form or circle or center radius? How is this helpful? Let me scroll up and look at your. Okay, you said center radius form, at least initially. Circle radius is the standard form. Oh, okay, so yeah. Well, this is center radius form because you can clearly see the center and the radius inside the equation. The general form, you would multiply out the squareds and subtract the 4 over to this side, and that'd be the general form, but unless you want to see that, I won't do it. I don't know why you would ever want it in general form, but I guess it exists. If you got the C note to circle? I guess so, yeah. If you run into an x squared and a y squared like that. Well, do you know it's not an ellipse? Oh, no, you do need a coefficient in front of the x squared or the y squared for it to be an ellipse. The general form of equation makes it difficult to find any meaningful properties about the circle. Yeah. I guess, yeah, it is possible that you run into an x squared plus a y squared in a different context and you end up having a circle as your answer. So I guess that angle makes sense, Alti. All right, so yes, sorry about that confusion, sphere base. I basically never see circles in general form, so it doesn't come to mind. All right, so here's a calculus question. Unless there's anything further from chat, I'll work. Let's take a look at this question. A rock is thrown upward on the planet Mars. Its height in meters t seconds later is given by y equals 10t minus 1.86 t squared. Really? Is the gravity on Mars 1.86 meters per second squared? Oh no, that'd be half. So 3 point. I'm just curious about this. 3.73. Interesting. Okay. That's a third of Earth, about. Funny. Isn't the moon? The moon is like a sixth. That's like really close. Yeah, Jed, this is the general equation for free fall. Your initial velocity is
Nobody
10.
makes me bleed my own blood.
Based.
Nobody.
Thank you so much for subbing. I appreciate you. You don't have to do that, but I appreciate that you do. Nobody makes me bleed my own blood. Yeah, it's just the equation for projectile motion, Jed. It's only the y initial velocity, but it's the 10. And the average velocity v sub 1 comma t for t equals 2, 1.5, 1.1. The average velocity. Oh, I see. That's what the sub 1 comma t means. Wait, plug? Can't figure out how it resulted to the highlighted part. Oh, they're asking about this highlighted part, I guess. Okay. Um, I keep on looking at the plug part and wondering what that means, but that's not what they're asking about, so I should just ignore it. Yeah, how, when? Uh, they do some fancy algebra from this step to this step. Let's just see if we can follow it. It seems like a weird way to get a cancellation. Wait, okay. The red marker, like, it pops nicely, but it takes forever to erase. So let's take the step before, write it down, because I don't see anything wrong with it. 1.86 t squared minus 10 times 1 minus 1.86. Let's just skip to the 10 minus 1.86 is 8.14? Question mark? Yeah, I can do math. Yeah, okay. Over t minus 1. And then they're trying to engineer a situation where they get a cancellation with the t minus 1 on the bottom. And I assume they must complete the square. So if they have a 10t minus 1, okay, well, yeah, well, I'm going to focus on just the 10t first, and the constant. If we need to end up with a 10 times t minus 1 in parentheses, we need to make this into 10. So I'm going to do plus and minus 1 point. I literally just did this math. 86 minus 1.86. And so we can take that minus that to get 10t minus 10. 10t minus 10 minus 1.86 t squared plus 1.86. That 1.86 is what left over from there over t minus 1. So we can factor that to get a 10 times t minus 1. And then over here, I'm still not sure what we're going to do. I guess, oh, actually, we factor out a minus 1.86. Okay, that actually works out. 1.86 t squared minus 1 over t minus 1. And then you factor out that as a difference of two squares. Okay, that's not as bad as I thought it'd be. It's definitely not what I would have thought to do with this problem, but it's nice that it works out. 1.86 t plus 1, t minus 1 over t minus 1. Then all the t minus 1s can cancel because they're in all the terms. You end up with 10 minus 1.86 t plus 1. Okay. That's how they get to that highlighted step. Let's see if we can explain that in a comment. Just expand this baby back out. Refresh to see if someone else beat me to it. They didn't. Good. It's some funky algebra. But the goal was to cancel out the t minus 1 on the bottom by engineering a situation where we have t minus 1's minus 1 terms, or factors on top. Paracone, what is your view on umbral calculus? I've never heard of that. Sounds... Actually, it sounds like witchcraft, and I feel like I've said that exact same... It's maybe a hybrid of umbral calculus. So I feel like I feel like deja vu with saying that it feels like witchcraft. Oh, if it involves sequences, I probably don't like it. Oh god. So math thing is stressing my fruity creative type. Oh, no worries, super base. I'm happy to. I love helping people just like get through their math classes. So if you do run into any other questions, please feel free to like drop by, and I promise I won't explain it in such a confusing way again. Terracone, I have never studied this. It does not look like the type of math that I would enjoy, though. I like very like applied things like differential equations. And honestly, the thing I like the most is just helping other people understand the things that I know. But the areas of math that like I like are mostly like differential equations or like, you know, modeling. Yeah, that makes you stressed out. It makes me stressed out too. um, Rearranging the top to 10t minus 1.86 t squared minus 8.14. Actually, is this even a good idea? Oh no, this is a bad idea. Doing this step, actually I unknowingly like had to undo the subtraction later. They start by keeping the 10 times 1 minus 1 point, or I say 10 minus 1.86 on top as 10 minus 1.86 rather than subtracting it. Rearrange it to get 10t minus 10 minus 1.86 t squared plus 1.86 Let me put some brackets on this. Over t minus 1. The sqrt area of combinatorics can be used to solve differential relations. Notice it's discrete. I did see that there were like the choose involved. Yeah, I've never liked combinatorics in general, and that maybe throwing calculus into the mix might make it more interesting, but I think I would just get very confused. I'm sure it does lead to some interesting results, but it's not the type of math that they look into. 10 t minus 1, and factor the minus 1.86 t squared plus 1.86 into minus 1.86 t squared. Or no, 1.86 t squared minus 1.86. We now have 10t minus 1 minus... Wait, I did that wrong. Minus 1. Over t minus 1. Only 2 more steps. T squared minus 1 as the difference of 2 squares to get... not that far even, Terracone. I majored in applied math. And so honestly, yeah, I never did that. The farthest I've gone in algebra is linear algebra. So not much. Or like I only have an undergrad degree is probably a better way of saying it. And I tend to avoid those very... Or I'm definitely like not good at those algebra things. Now we have t minus 1 factors everywhere. We can cancel them. To get the part after the highlight. You're going to require to do group theory? Oh, dang. I had to study it a tiny bit, and I understood the very bare basics and nothing more. Like, I couldn't do anything with it. There are some people who come in and know some group theory, but yeah, it's not something that I can help with. I'm sorry. Okay, hopefully this helps the person. Is it just U sub? This one could be fun. You Lambert W pilled your math friends today. You know, seeing the power of non-elementary functions. My only experience with the Lambert function is when Wolfram Alpha gives me an answer involving. I was like, oh nope, I did something wrong. Abort. Okay, this one isn't too bad. It definitely is gonna be a U sub. Let's go through though, because integration is fun. I'm sure they are powerful, but I don't know them. Why do them? I can just rewrite the question. Be much smarter than resizing the window every time. Okay, blank that out. X squared over root x minus 6 dx. So yeah, so we can just do a U sub on this to make this a lot simpler. The complicated part here is the root x minus 6. So I'm going to say u equals x minus 6, which means du is equal to dx, and let's plug it in. Actually, there's going to be a little thing here, because we know u equals x minus 6, so to do with the x squared, we rearrange this to solve it for x. So we add 6 to each side to get x equals u plus 6. Integration is fun and required by law since 1954. Yeah. All right, that's a good one. So instead of x squared, we have u plus 6 squared. And then we have x minus 6 is u, so we have root u du now. Now we want to multiply out the top. We get u squared plus 12u plus 36 over root u du. And now the simplest way to deal with this whole situation is to split it up into 3 fractions based on the numerator. So our first fraction is u squared over root u. Second fraction is 12u over root u. The last fraction is 36 over root u. And now we can simplify u squared over u. If you remember your exponent rules, becomes u to the 3 over 2. Similarly here, u to the 1 over u to the 1/2 becomes u to the 1/2. And that just kind of is. I'll rewrite it, make it consistent though, to negative 1/2, just negating the exponent. Now that's something that we know how to integrate just using the power rule. You add 1 to the exponent and divide by the new exponent. So add 1 to 3 over 2, you get 2 over 5, u to the 5 over 2. Same thing over here. We get 3 over 2, so we multiply by 2/3. 2/3 of 12 is 8. 8u to the 3 over 2. Add 1 there, divide by 1/2, it's multiplying by 2, plus 24u to the 1/2. I mean, if you want to go wild, you can do plus c. I mean, I won't do it now because I don't like doing the c until we've unsubbed, actually. So let's unsub now, and then we'll remember to do plus c maybe after. U equals x minus 6, so we get 2 over 5, x minus 6 to the 5 over 2, plus 8, x minus 6 to the 3 over 2, plus 24u, oops, not you, or me, x minus 6 to the 1/2. You could write it as root x minus 6, but it's your choice, plus c. Now, I'm not going to do all that, or I'm not going to show all that in the right answer because I just want to know if it was a u sub. That's all I'll answer, but it's always fun to just do the integration. So u sub with u equals x minus 6. So I'll give them what u sub is, and then I'll leave it at that so they can solve it for themselves.